Okay, so I am now recording this. So if for some reason you want to come back and look at this, if I go too quickly through something, please feel free to do that. You have probably noticed that every time we meet, the first thing I start off with is a warm-up activity of some sort. And I'd like to just talk just real quickly about why that is. First of all, what I've tried to do throughout the course of this semester is to review things that we've been doing the previous time we met. So most of the warm-ups are usually what we've done just the previous day or the previous week. So this is, these problems are all actually from chapter 2. So you'd have to go back in time to, I think in October to remember when we did these things, but hopefully you've been reviewing for the final exam. As you know, we're only meeting a couple of times a week. And the point I'm trying to make is this. Guess how you get good at math? Doing math. You don't get good at math watching me do math. Now, by the way, that helps you understand maybe what you need to do, but people get better by practicing what it is they're trying to get better at. If you want to get better at chapter 2 type of stuff, do chapter 2 type of stuff. If you want to get better at finding the extrema of a curve, do extrema problems and you will get better at it, okay? So that's the first thing. And then one other thing I want to mention before I go any further and forget. This presentation is yours if you would like to have it. Please just send me an email. Say, hey, Mr. Allen, can I have that PowerPoint? I will be glad to send this to you, and then you can have it, okay? So, so question 1 says use the limit process to find that derivative. Question 2 says find the second derivative. That's the derivative of that function. Question 3 says find the equation of a tangent line to that curve. And then question 4, what is the first derivative of this? So what I've got now on the next page is actually all of the answers, okay? I just worked these out on my paper and I took a picture and I scanned that. So just to let you know, to do number 1, you have to use the limit definition of a derivative. And we spent some time on this because I needed you guys to know that a derivative is a limit. And it turns out that the answer there is 2x. Now, you could have just cheated and just jumped using your power rule to 2x. But if you recall, we had a test, actually, the test on chapter 2. You actually had to do something like this on that test. Question number 2, you just got to do the derivative twice using our different rules. The derivative of e to the x is e to the x, and the derivative of e to the x is e to the x. And then, of course, use your power rule and the derivatives of sine and cosine. Your final answer there, the second derivative, is e to the x plus 10 plus the cosine of x. Question 3, probably the most important question that calculus answers is how to write the equation of a tangent line. In fact, that's how we started chapter 2. And of course, here I did not use the formal definition. Here I just used the quotient rule, which is low d high minus high d low over low low. Turns out that the slope of the tangent line, which is found by using the first derivative and then plugging 0 in for it, gives you a slope of 3 over 16. We know that x is 0. Well, y turns out to be 1/4. So a good answer there would be y minus 1/4 equals 3/16 times the quantity x minus 0. And finally, last but not least, question number 4, that is a chain rule problem. And so you use the chain rule. You'll get a final answer there for y prime equals 6 pi x secant squared quantity pi x squared. Does anybody have any questions on the warm-up? Any questions? If you do, please feel free to unmute yourself and ask, or you can just put it in the chat. Otherwise, I'm going to move on. Okay, so I'm going to go ahead and move on since there's no questions. If you have a question, feel free to type it in the chat or just unmute yourself. All right, so I'd like to give you a general overview of what you should expect on the final exam. Number 1, the exam will be 75 minutes. That's how much time they've given us for each of the classes that day, even though really it's a 90-minute period. They're trying to give you guys a little bit of a break between classes. Also, for those students that get extra time on exams, it gives them a little bit of extra time. So you'll have 75, in other words, you'll have the entire period to take the exam. There will be 2 parts. There will be a multiple choice part, and there will be a free response. Topics include Chapter 1, which is on limits, Chapter 2, which is on derivatives, which is what we just looked at, and then Chapter 3, which is on the applications of derivatives. Now, as I've mentioned earlier, since we've been kind of in this pandemic mode and doing all this virtual and hybrid learning, we're about one chapter behind where we need to be, but that's okay. I mean, I guess it just has to be okay. So it doesn't even matter if it's okay. We're behind, and that's okay. A few more details about the test. Number one, there will be exactly 16 multiple choice questions. 16 multiple choice questions. There will be one free response question, which will have multiple parts. So this is these are the kinds of questions where it might say at the top it gives you some sort of equation, and then maybe question A, I ask you to do the limit. Maybe question B, I ask you to do the derivative, and then question C, maybe I ask you to find the concavity. Now I'm just going to tell you this question here, this free response question, you will have to work that out on your own paper, take a picture of it, and upload it. Okay? So please make sure you're prepared to do that. Please make sure that you're ready to do that. And this is something that you'll have to probably do when you actually take the AP exam on May 4th. You should be proficient at using your calculator to do calculus-y things. If you go to my Canvas page, which I'm not going to do right now, but you may recall that up towards the top, at the very top, is all the lessons that I've done. But right below that, there's several videos that I've posted on how to do certain things with calculus in your calculator. If you haven't watched those and you're not sure how to, for example, graph the derivative of a function, you might want to consider doing that. Also, in general, in this class, make sure you round to 3 decimal places. Oh, I guess I should add one other thing. Don't forget, your calculator needs to be in radians. Make sure that your calculator is in radians. That might be a good little reminder to put here. Make sure that your calculator is in radians. So any questions that involve trig functions, you need to be in radians. Please make sure you're not in degrees. Okay, so now what I'm going to do is I'm going to go step by step through each of the chapters, and I'm going to kind of highlight what we did, and I'm going to ask a couple of key questions. And just to be honest with you, I'm going to go ahead and call on you, so be ready when I call on you. So chapter number 1, which was on limits, we did finding limits graphically and numerically. That was all the way back in like early August. Section 1.3 is evaluating limits analytically. 1.4 is on continuity and one-sided limits. Section 1 is infinite limits. And section 1.6 is limits at infinity. So those are the sections we covered in chapter 1. Question 1, what is a limit and why do we care? Would anyone, I'll give you just a second if someone wants to volunteer. Who can tell me what is a limit and why do we care?
A limit is a predicted y value.
Great. That's exactly right, Dagan. Do you know why we care?
It allows us to find the tangent line and secant line.
Correct. And specifically the tangent line, right? The secant line we can do with just algebra, but we just talked about on the warm-up that what is a derivative? It is a limit. So if you don't know how to do limits, you don't actually know how to do calculus. Now, second semester, we're going to start right off in chapter 4. We're going to talk about this thing called integration. Guess what an integral is? It's a limit as well. In fact, basically everything that calculus is based on the foundation of limits. Anybody want to tell me why do we care about continuity? Why is continuity important?
If something isn't continuous, it's not differentiable.
That's a good point. Thanks, Dagan. It turns out that if you look at all the theorems that we do in chapter number 3, the chapter we just did, just go back and look at any theorem you want. Almost every one of them asks that the function be continuous. So continuity is a big issue because if a function is not continuous, a lot of times, like the mean value theorem, does not apply if it's not continuous. What is the difference between an infinite limit and a limit at infinity?
No digging.
William.
Oh man, I lost my train of thought. You gotta be kidding me. Well, an infinite limit is when, like, at an x value, the limit would be infinity.
Yep.
And then,
what is that then? When you have that situation, what do we have graphically?
An asymptote?
Correct. What kind of asymptote?
Vertical.
Perfect. Continue.
All right, and then limits at infinity would be a horizontal asymptote, which would mean what number would the y value be if that x eventually somehow reached infinity?
Now I'm getting very excited right now because it is clear by me asking these are I'm not actually asking you to calculate anything on these questions, but when I go through these questions, if you're like, I have no idea, then we got a problem. But if you're like, oh, I know what an infinite limit is, that's our definition for a vertical asymptote. That's good. Now, I'm not saying you can't have a reference sheet. In fact, I encourage you to have reference sheets, but these are things that we've spent time on and you should know how to do them. Okay, so let's move on to chapter 2. Chapter 2 is on differentiation. So we covered 7 sections. So this was kind of our biggest chapter, if you will. Section 2.1 was basically on the derivative and tangent line problem. Basic differentiation rules, so that's like our power rule, the derivative of sine, etc. Product and quotient rules, the chain rule, implicit differentiation, derivative of the inverse. I'll put a little star next to this, okay? And here's why I'm actually, maybe star is not a good way to put this. This particular section, I skipped this and I left that to you. And the reason I did that is on the AP exam, you might see one question on that topic. It's not a hard topic. It's not anything I want you to spend a lot of time worrying about, but I kind of skipped over that. And then, of course, section 2.7, which I think is the hardest section in the first semester, which is related rates, which is just a fancy way of saying story problems. So what are our key questions? Okay, what is a derivative? We already have answered that today. And why do we care? Dagan's already answered that. And it's basically a derivative is a limit, and it's going to allow us to get the instantaneous rate of change. It's going to allow us to find the slope of the tangent line. How do we calculate or how do we determine derivatives?
You can use the defined. You can use the defined derivative formula, or you can use
the formal
power rule,
definition.
chain rule.
Yep.
Yeah, or the quotient rule. All those rules.
Yep. Or you could use the shortcut rules, right?
Yeah.
That's basically what I need you to know. When it comes to actually calculating derivatives, you can use the formal definition, which, by the way, I would never do unless they asked me to, or I would use the shortcuts. Now, please don't forget that when you're doing these derivatives, to be very careful to not get things mixed up in your head. And this is something that sometimes students do. They start getting quotient rule confused with power rule and things like this. So make sure you know your rules. Chapter 2, and let me go back to this slide. This is rules. This is rules. Shortcuts, if you will. This is rules. This is really kind of rules too. It's kind of just a step-by-step process. In fact, this is even a rule. It's just how do we calculate derivatives? What are a couple of reasons we've studied implicit differentiation? Can anyone think of why in the world do we care about implicit differentiation? Let me give you an example of an equation that is written implicitly. Why do we care about implicit differentiation? Okay, so a couple of reasons. Number one, sometimes, now in this case, could I solve this equation for y? Sure, I could. But in other cases, you cannot solve for y. And if you couldn't solve for y, then you'd not be able to figure out what the derivative is. But since we can, in this case, we didn't have to use implicit differentiation here, but we could. Other equations, let me make an uglier one. Let's say xy third plus sine x minus x squared y to the fourth equals 10 or something. You can't solve that for y. At least I don't think you can. No, you can't. So you wouldn't be able to do this one. The good news is with implicit differentiation, you can. But the main reason we do implicit differentiation, at least in this class, is to be able to solve related rate problems. All of the related rate problems in chapter 2, section 7. And by the way, related rate problems, those are kind of good AP calculus questions to be able to do because those are applications of differentiation. Okay, chapter 3. Chapter 3, this is what we just wrapped up with. These are applications of differentiation. So we covered section 3.1, which is extrema. And on this particular section, we looked specifically at extrema on a closed interval. Rolle's theorem and the mean value theorem, aka MVT. Increasing, decreasing functions in the first derivative test. Concavity in the second derivative test. Curve sketching. And then finally, optimization. And again, optimization problems, those are tough for students because those are your word problems. So if we look at this, these are the tough questions, but really, these are the kind of questions that kind of spurred the development of all the stuff above there. I mean, it's really nice that you can figure out the high point or a low point on a curve, but what's more useful is, can you actually maximize the profit function for a company? Or can you minimize the amount of, I don't know, expense for a company? So let's look at some big questions. What are extrema and why do we care? What are extrema and why do we care?
It's the relative maximum and the relative minimum.
Yep. And why do we care, Jeffrey?
We care because it, like if you want to find out like the overall trend of the graph, you want to be able to figure out if it's like concave up or concave down or, how the graph looks. It's important to find the extrema first.
Right. Well, and here's another thing too, Jeffrey. If you think about, if I graph the, let's say, profit graph of a company, if somehow we figured out this equation that basically represents their profit, guess what we want to do with that profit? We want to maximize it. We want to make as much profit as we can. I mean, if that's what we do in business, our goal is to make as much money as we can. We want to maybe maximize that. Or maybe we're talking about, we're worried about our diet, and I'm just talking about myself because the bodybuilding thing, but I'm trying to maximize the amount of protein I get. And I've got some fancy curve that basically shows, how my food consumption can be. And I want to maximize the amount of protein, let's say, or I want to minimize the amount of fat. So that's why we want to know about extrema. And this is this is probably the most important question in this chapter. How do we reduce the number of locations of extrema? In other words, what I'm saying is, how many points are on a curve? Infinitely many, correct? If you have to check infinitely many things, you will never get done. So how do we reduce the number of locations and I should have wrote the word possible extrema. How do we do that?
You use the first derivative test to find critical numbers?
You're correct and incorrect.
Oh.
You're correct when you said critical numbers, and that's what we need to get. The key is critical numbers. So Dagan, be careful here. It's not the first derivative test, though. The first derivative test allows us to figure out extrema. By the way, those have to happen at critical numbers. So the answer is, how do we reduce the number? We find the critical numbers for a curve. Now, or an equation. What I'm going to tell you is most of the equations, in fact, all the ones you're going to deal with in my class are going to have a finite number of critical numbers. Typically 1, 2, 3, or something like that. Now, it can be that certain curves have infinitely many critical numbers, like the sine curve, for example. But most of the time, we're only going to have to check 2, 3, 4, maybe 5 points is the worst case scenario instead of infinitely many. So this is why we call them critical. They're critical because they help us reduce the amount of work that we need to do. And you got to keep in mind, calculus was developed before people had graphing calculators and computers that could do all this stuff for them. And when you guys take the AP exam this spring, assuming it's still in person, you're going to have to do half of that exam. In fact, it's actually a little bit more than half of it is without a calculator. Okay, what is the key difference between the first and second derivative test? This is like a no-brainer. I don't even think you have to know calculus to know this one.
For the first derivative test,
Go ahead,
use
Nathan.
derivative, and for the second, use the second derivative.
I know, isn't that silly? It's so silly. Now, I'm just going to let you know, both of these things are related to the extrema, or as I think it was Jeffrey said, the relative extrema. The first derivative test, you use the critical numbers in the first derivative to determine if it's a min or a max. For the second derivative test, you use the second derivative test. You plug in the critical numbers of the second derivative into that. So that's the only difference, okay? All right, I'm going to go back to this last slide. So I've kind of tried to cover, and I didn't really do any examples yet, but I tried to cover, I just summarized basically what we've done so far semester 1 of Calc AB. Does anyone have any quick questions about anything I said or went over these last few slides before I move on to the next part of what I want to do today?
Could you possibly go over finding the derivative through the limit process?
Yes.
Okay.
Like on the warm-up?
Yeah.
Okay. I'm going to go, actually, I'm just going to use this right here. So let's say, I can't remember what the problem was in the warm-up, but let's say it was x squared plus 3. Okay, I can't remember what it was, but something like this. So you're trying to find the derivative using the limiting process. So y prime, by definition, is the limit as h goes to 0 of f of x plus h minus f of x over h. This is how we find the derivative. In fact, if you guys can take yourselves back to section 2.1, when we went over this, I told you that this is probably the most important thing that you will learn this semester. This is the formal definition of what a derivative is. Everything else in chapter 2 is a shortcut. So here's the definition. So we're going to do that. Now, notice that this is actually our f of x in this case. So what we're going to do now is we're just going to substitute things in. So f of x here is x squared. So I'm going to put x plus h in for the x plus 3. And then I need to minus f of x, which is x squared plus 3. Now, as you notice, I've kind of picked kind of an easier example here because I don't want to get too caught up in the minutia. But all I've done now is I have taken my definition. This is my formal definition right here. And I have plugged f of x into that formal definition. So now we can go ahead and work this out by doing a little bit of algebra. So this is going to be x squared plus 2xh plus h squared plus 3 minus x squared minus 3. Notice I was careful to use my distributive property here. And now good things start happening. This plus 3 and that minus 3 cancels. This x squared and that x squared cancels. So that tells us this is now the limit as h goes to 0 of 2xh plus h squared all over h. Well, the good news is this h in the denominator cancels that h in the numerator and this h right here. So that tells us that this is going to be equal to the limit as h goes to 0 of 2x plus h. And if h goes to 0, that means that h is 0. So our final answer here is 2x. That is what y prime is. And remember, y prime equals 2x is the derivative of y. It will allow us to calculate the tangent line for this curve for any value of x. So if you said, hey, Mr. Allen, what is the slope of the tangent line when x is equal to -5 halves? Guess what the answer is? Well, I take this -5/2 and I'd put it right in there. The 2's would cancel, and it's -5. The slope of the tangent line is equal to -5 there. Does that answer your question, Will?
Yeah, I just got one little question about that. And I don't know, it might be a stupid question. So when we do it that way, are we always going to put it as the limit as h goes to 0?
Yes.
Okay, I'm just making sure that that's always going to.
Now, let me remind you, though, there were 3 variations of this. This is the most general one, and this is the one that I recommend that you remember. But we also were given a formula for the slope of a tangent line. That was the very first formula. And then I also gave you a formula that was quotient of the difference quotient definition. Okay, and we can talk about those another time, but this is the main thing that you want to do. And just one other final thing before I move on. If you guys remember, originally we didn't call it x or h, we called it delta x, the change in x. Remember that delta x is a small change in x anyways. Okay, any other questions? Okay, I'm going to go ahead and move on. So before I get into the next phase here, I just want to remind you, don't forget that you have an assignment due Friday, tomorrow night at 9 p.m. It is not WebAssign, though. It is on myap.collegeboard.org. I've already seen that some of you already have started it, and I think a few of you have even finished it, and that's great. It is review questions from the entire semester. They are all AP type of questions. And I think I put one free response type question where you have to take a picture and upload it, because I want to get you guys kind of in that habit of being able to show your work as well, even though most of them are multiple choice. They're kind of interesting questions. But nonetheless, does anyone have any questions on this? By the way, this is your last homework assignment for this semester. So tomorrow night at 9 p.m., we're done. That's it in terms of homework. Everything's done except for the final, which will be next week. And by the way, your final next week, I think, is Thursday. Isn't that correct? So that's good news for you guys. You'll get a couple of extra days to study and all that. So, okay.
That College Board assignment is just the semester 1 review thing, right?
Yeah.
Okay,
Yep.
sure.
Yep. No, good question. All right. So I gave you guys a review on the Canvas page that looks something like this. It says Calc Semester 1 Review, Exam Review. Have you guys, raise your hand if you've looked at that. Okay. So, and this class isn't as big of a deal. My 5th period class, they have to take the final exam on Monday. So they're kind of under the gun a little bit more. But does anyone have any questions about this? Right. We could kind of spend more time on this on Monday if you'd like. But does anyone have like a burning question about any of the questions on that review at this point?
So we are meeting with you on Monday, even though we're not taking our final on Monday?
Yes.
Okay.
Yep. Just join me. Join me for 45 minutes, and then you're free to go. There's no homework or anything to do, but yeah, I think you should join me.
Is that just going to be another review day?
It'll be just another review day.
All right.
And guys, I'm not saying this. In fact, so Monday, if you feel like you're good, if you will at least log in for the first minute or two, log in, then I'm okay with if you need to prepare for another final. I don't know if that's why you're asking me that, Lucy. But I kind of expect you guys to be here. But like, let's just say Ravana is like, Mr. Allen, I've got an exam period 5 and I'm really stressed out about it and I need to get ready for that. Can I spend time reviewing for that instead of staying that I'm not going to be upset about that. Does that make sense? So, okay, good. Today's kind of like our last quote unquote official day. Like I'm requiring you guys to be here for the full 45. Okay.
Are the answers to the review going to be posted?
Yeah. Is that on there yet? Have I put that on there?
Last time I checked, it wasn't on there yet.
Okay. Okay. So would you do me a favor, Rachel? Would you just take like 30 seconds and just say, hey, Mr. Allen, can you post those answers? And I will do that.
Like in an email?
Yeah, just send me an email, please, just to remind
Okay.
me, because I don't want to forget. And then you'll be like, Mr. Allen, you said you were going to, and I'll be glad to get those up. And I'll probably post them, if you don't mind, I'll probably post them by tomorrow. I usually kind of wait till like not the last minute, but I want to make sure everyone, your best bet, and I'm speaking to all of you now, is if you honestly are trying to review for this final, is at the very minimum, do the review that I gave you. But that doesn't mean you shouldn't be going back and looking back over some of those extra problems I gave you, some maybe rewatch some videos. Guys, I can see who's watching my videos, or not who, but I can see how many people. A lot of students don't watch my videos. And look, I know they're not the most exciting videos, but if you don't know how to do the mean value theorem, it might be a good idea for you to watch the video, or maybe watch one of the extra videos I posted. Okay, anyways. So now we have about 8 minutes left in class. So I'm going to at least get started here. But I need your guys' feedback. We've got one of two options here. In fact, let me get a poll going, because I'm going to give you a choice. We can either play Jeopardy or we can play Kahoot to review. Since you guys didn't have a lot of questions for me, I'm going to start a poll, and I want your input on which one you want to do. Oops, if I can spell which one. Hold on, I'm going to give you a poll. Don't answer yet, Mr. Quinlan. Okay, so let's see here. We're going to say, let me do this in the right order. Okay, here comes the poll right now. Please vote. Okay, wow. So the majority of you want to do Kahoot, and that's fine with me, okay? That's absolutely fine. So what we're going to do now is we have about 6 minutes left in class. I'm keeping track. So for the next 6 minutes, we're going to play Kahoot. If I'm going to keep playing until the end. Yeah, I know, that's sad. Anyways, we're going to keep playing. If we don't get done in the 6 minutes and you want to keep playing for review, you can. I'm not sure how well this is going to show, so you guys might have to give me some feedback. But we'll go ahead and do Kahoot. Let's go ahead and keep that for right now. Okay, it says loading game pin. There's our game pin.